In our last lesson, we talked about the idea of limits, about what happens to some graph as x gets really close to some number. Well, today I'm going to drill in that a little deeper and talk about a more formal definition of limits. Specifically, the one in front of you that says the limit of f of x as x approaches some number c equals to L, some number L, if and only if. That if and only if right there. The limit from the left side, notice the C with the minus sign there? The limit from the left side equals to L, and the limit from the right side, notice the plus sign, equals to L. We have to look at limits from both sides at that point. So let me give an example of one where the limit would not exist. In front of you I have the equation f of x equals to the absolute value of x minus 2 divided by x minus 2. Now, absolute value, if you remember right, has two solutions to it, a positive and a negative solution. I've graphed the solutions below. I typed in the calculator and graphed it below. And you will see that as we approach x from x equal 2, because we're asking the question, what is the limit as x approaches 2? Well, here's 2 right here, okay? As we approach it from the left side, as we pick x values that are really close to 2 from the left side, you can see that all of our y values are negative 1. All these y values down here are negative 1. As we approach 2 from the right-hand side, okay, we're coming at it from this direction, all of our y values up here are positive 1. Therefore, since the limit from the left side is negative 1, as we come at it from this direction is negative 1. As we come at it from this direction we get positive 1. That limit does not exist. Now here's one where the limit would exist. This is what's called a piecewise function. You have f of x equals to x squared minus 3 for x less than 2. Right there. You have x minus 1 for x greater than 2. Again, I've graphed it for you right here. The x squared minus 3, well, that's a parabola. And it's a parabola all the way to the point of x equal to 2, right there. The x minus 1 is a linear equation. And it's linear all the way from 2 to infinity out this direction. Now you'll notice, look at the domain of this, that we didn't even include x equal to 2. So we can't ask the question, what is f of x, or f of 2 rather. We don't know what that is, because it's not in the domain. There's no equal sign for either one of those. Okay? But we still can talk about limits. The limit, as we approach 2, the limit as we approach 2, from the left-hand side, we're looking at this equation as we approach from the left-hand side. Well, as we get really close to 2, our y values are approaching 1, right there, okay? And as we approach from the right-hand side, we're using the linear equation right there. As we approach from the right-hand side, we're coming at it this way, okay? As we get really close, our y values are approaching 1 as well. Therefore, the limit as f of x, as x approaches 2, is 1. Because from both sides we get to the same point. Next lesson we'll talk about one-sided limits.